Welcome to the 27th explainer in the series of research methodology titled Reliability and Validity. Okay, let's jump right into this. Today, we are exploring the two absolute fundamental pillars that determine the trustworthiness of any research study out there. I'm talking about reliability and validity. It doesn't matter if you're looking at psychological testing, complex social science inquiry, cutting-edge health research, or educational surveys. These two concepts, they are the ultimate gold standard for judging the quality of research instruments. And they matter so much because, without them, even the most fascinating, beautifully presented, and supposedly groundbreaking research findings are essentially built on sand. If we can't trust the foundation, well, we just can't trust the house. So before we can blindly trust the results of any educational, psychological, or health study, we have to pause. We have to take a step back and ask an incredibly basic but absolutely crucial question. Are the tools used to gather this data actually doing their job? You know, it's incredibly easy to scroll through your feed and see some flashy headline claiming a new teaching method completely revolutionizes math scores overnight, or that some specific miracle morning routine is definitively linked to lower anxiety. But how do we know that research is actually true? Think about what happens if we just take that headline at face value without ever checking the methodology. You might have entire school districts spending millions of dollars of taxpayer money buying into a program that just plain doesn't work. The answer to avoiding these massively costly mistakes always comes back to the quality of the measurement. If the measurement itself is flawed, the entire conclusion is compromised from day one. To really wrap our heads around this, we first need to define what we mean by a measurement instrument. Let's think about it this way. This is simply a tool used by researchers to collect data. That's it. That could be a questionnaire you fill out online, a standardized test in a classroom, a structured interview schedule, or an observation scale used by a researcher in a lab. Now, a research study might look absolutely brilliantly designed on paper. It might boast tens of thousands of participants and have secured extremely impressive funding from prestigious name-brand institutions. But if its measurement instruments are fundamentally flawed, the entire foundation of that research collapses. Literally all of that funding, all of those countless participants, and all of those hours of work mean absolutely nothing. Everything hinges on these tools producing consistent, accurate, and meaningful results. Here is our quick roadmap for this explainer. We're going to start by defining the problem of untrustworthy data. Then we'll unpack the concepts of reliability and validity individually. After that, we'll explore how they interact and finish up with why better measurement actually matters out there in the real world. Let's dive into our first section and look at exactly why establishing the trustworthiness of research is so incredibly critical right out of the gate. When researchers use flawed questionnaires or biased interview schedules, they introduce errors that even the most sophisticated, supercomputer-powered statistical analysis cannot fix later on. You simply cannot math your way out of bad data. Imagine for a second you are studying classroom behavior, but your observation tool is so incredibly confusing that two different observers record completely different behaviors for the exact same student over a simple 10-minute period. One observer marks the student as highly engaged, and the other marks them as totally distracted. If your highly trained observers can't even agree on what they are seeing with their own eyes, your data isn't just flawed, it's pure fiction. Or imagine a survey where the questions are double-barreled and confusing, like asking, "Do you enjoy math and science?" Well, how on earth do you answer that if you absolutely love math, but you completely hate science? The data the researcher gets back is essentially just noise. If his study's instruments are broken, the findings become weak, questionable, and frankly, completely useless. Let's move to our second section and establish our first major pillar. This is the consistency standard, otherwise known as reliability. So the absolute crucial point to grasp here is that reliability is all about dependability. It's asking one thing: does this instrument give you similar outcomes if you use it repeatedly under similar conditions? Essentially, it is about stability over time. Say a student takes the exact same intelligence test on a Monday and then again on a Friday. If their scores are wildly different without any real change in their actual cognitive ability, well, that test is totally unreliable. It's plagued by what we in the field call random error. Now, random error could be anything. It could be unclear questions, poor instructions, or even just temporary changes like the testing room being way too hot on Friday, or the student just having a really bad morning. Reliability means achieving freedom from that random error, so you can actually trust the consistency of your results. Now, we've all stepped on a scale we swore had to be broken, right? Well, this brilliantly illustrates the concept. We call it the weighing machine metaphor. Imagine you step on your bathroom scale tomorrow morning, and it consistently shows exactly 5 kilograms more than your actual true weight. every single time you step on it, Monday, Wednesday, Friday, next month, it gives you that exact same incorrect number. Now, here's the wild part. That scale is highly reliable, even though it's completely mathematically wrong. This is such a vital concept to grasp because reliability does not prove an instrument measures the right thing. It only proves that it measures something consistently without bouncing around with random error. It is perfectly dependable, even in its inaccuracy. Because it is so fundamentally important, researchers test this consistency in several different ways. They've developed very specific methods to measure it, so let's break these down simply. First up is test-retest reliability. Think of this like taking a personality quiz on a Monday and taking it again a month later. Your broad personality traits shouldn't have completely flipped overnight, so the scores should generally match. Next is parallel forms reliability. This is like when a teacher creates a Form A and Form B of a math test, so kids sitting next to each other can't cheat. The tests are different, sure, but they have to be equally difficult to be considered reliable. Then there is split-half reliability. This is literally just checking if the odd-numbered questions on a test give you the same general score as the even-numbered questions on that exact same test. It ensures the whole test is balanced. Internal consistency takes that idea a step further. It asks, are all the questions pointing in the same direction? If you have a 10-question survey on depression, every single question should relate to that overarching topic. Researchers use a statistical tool for this, often called Cronbach's alpha, which is basically just a math formula that checks if all the items on a scale are rowing the boat in the exact same direction. And finally, inter-rater reliability. Think of Olympic diving. If two judges watch the exact same dive, they should give it roughly the same score. If one gives a 10 and the other gives a 2, human judgment is failing the reliability test. Now, let's pivot to our third section and look at the second pillar. This one solves the problem of measuring the wrong thing. This is validity. Unlike reliability, validity asks a much harder question. While reliability just requires the math to be consistent day in and day out, validity is actually seeking the truth. Are we actually hitting the correct target? And more importantly, are the conclusions we are drawing from these scores actually justified? This is all about the accuracy, the appropriateness, and the real-world meaningfulness of the interpretation. A valid instrument provides concrete evidence that the conclusions drawn from the data actually make sense out in the real world, rather than just working in a pristine, vacuum-sealed academic bubble. Let's look at a really practical example. A valid reading comprehension test must measure comprehension, not merely vocabulary memorization, and definitely not how fast a student can physically write with a pencil. I know it sounds incredibly obvious, right? But you would be shocked at how often research accidentally measures the completely wrong thing. If you're testing reading ability, but a student fails because they just physically write slowly, your test is completely invalid. You measured motor skills, not reading. Similarly, if an instrument claims to measure job satisfaction, it has to accurately capture complex dimensions like the work environment, the relationship with supervision, and career growth potential. If that survey only asks about how much money someone makes, it's not a valid measure of overall job satisfaction. It's literally just a measure of salary satisfaction. Just like reliability, validity requires multiple forms of evidence to be proven, and each type tells a completely different part of the story. First is face validity. This is literally the sniff test. It's just looking at the test on the surface and asking, hey, does this look like it measures what it's supposed to measure? Next is content validity. This ensures the test actually covers the full domain of the subject. If your final exam only tests Chapter 1, it totally lacks content validity because it completely ignored the rest of the semester's material. Criterion-related validity sees if the test can predict future outcomes. For instance, does a high SAT score actually accurately predict that a student will get good grades once they get to college? Then we have construct validity. Now, this one is highly complex. How do you actually put a firm number on something completely invisible, like creativity or motivation or grit? Construct validity ensures that your physical survey is accurately capturing that abstract, invisible theoretical concept. Finally, in experimental research, we look at internal validity, meaning did our new teaching method actually cause the grade improvement, or did the kids just happen to get extra sleep that week and do better? And external validity asks, okay, if this teaching method worked in a highly funded, wealthy suburban school, can it be generalized and successfully applied to a rural, underfunded school? Let's move to our fourth section and see how these two massive pillars build upon one another to create genuinely solid research. So let's look at the core difference between the two concepts, side by side, just to make sure we've got it. Reliability is answering if you are measuring consistently. Validity is answering if you are measuring correctly. You are looking for freedom from random error on one side and the meaningfulness of interpretation on the other. They are intimately, deeply related, but they act as distinctly different criteria for judging the overall big-picture quality of any research project. To summarize their differences really effectively, I always like to consider what happens when they fail. Think about it. If reliability is missing, your data is completely unstable. You can't trust the consistency from one day to the next, which makes it totally useless. But if validity is missing, your data is completely misleading. You might have perfectly consistent data, just like our broken weighing scale from earlier, giving you that same wrong weight every single day, but it leads you to a completely wrong conclusion about reality. And this brings us to a fantastic quote by Kurlinger and Lee that establishes the ultimate paradox in research methodology. Reliability is a necessary condition for validity, but it is not sufficient by itself. What this actually means in practice is that a tool can be highly reliable without being valid at all, but a tool literally cannot be truly valid if it is highly unreliable. Unstable bouncy scores simply cannot accurately represent a true concept. So reliability supports validity, sure, but validity absolutely demands additional, rigorous evidence that you are actually measuring the right thing. Let's move to our final section and examine how researchers can actually improve these metrics, and most importantly, why it's so vital that we do. Researchers can't just hope for good data. They must take concrete steps to improve their instruments. To boost reliability, you absolutely have to write clear, simple questions that don't contain double meanings or confusing jargon. You must standardize testing conditions so everyone, everywhere gets the exact same time limits and the exact same instructions. And crucially, you have to conduct pilot testing. Honestly, pilot testing is a researcher's best friend. It involves doing a small trial run of your study on a tiny group before the main event. This helps you catch confusing language or weird timing problems before it's too late and your budget is blown. Now, for validity, researchers need to clearly define their theoretical constructs from the jump, rely heavily on expert reviews to check their work, and constantly compare their shiny new instruments with already established, proven measures. And I do want to take a second here, because while we focused really heavily on quantitative data, the hard numbers and the statistics, it is super important to note that qualitative researchers studying deeply human experiences face these exact same challenges. Scholars like Lincoln and Guba use alternative criteria in their naturalistic inquiries. Instead of using the word validity, they seek credibility and transferability. Instead of reliability, they look for dependability. And they use confirmability to ensure neutrality. They achieve this through rigorous techniques like triangulation, which simply means cross-checking multiple different sources to find the actual truth, and member checking. Member checking is awesome. It's basically going back to the actual participants you interviewed and asking, hey, did I get your story right? Is this what you meant? This ensures their open-ended inquiries are just as incredibly trustworthy as a tightly controlled statistical survey. Ultimately, we have to remember that this isn't just some dry academic exercise confined to a dusty university library or a textbook. Reliable and valid measurement has real, tangible, sometimes scary consequences. Research findings frequently influence real-world policies, teaching practices, and massive organizational planning. In health research, reliable instruments are absolutely essential for accurate medical diagnosis. When flawed data is used in the real world, it can lead to deeply harmful clinical decisions, vast amounts of wasted taxpayer money on completely ineffective social programs, or disastrous organizational failures that can negatively impact thousands of everyday employees. As the prominent psychologist Samuel M.Sc brilliantly points out here, validity has a consequential dimension. If a poorly designed, invalid standardized test miscategorizes a young student's intelligence or learning ability at an early age, it can alter the classes they are put into, the attention they receive from teachers, and ultimately, it can change the entire trajectory of that child's life. The stakes for getting measurement right are incredibly, incredibly high. It is literally about making sure the tools we use to understand the world don't end up hurting the real people living in it. I'll leave you with this final thought to consider. The next time you consume a piece of research or see a flashy, data-driven headline in the news, I want you to pause and ask yourself, was the instrument they used measuring consistently, or was it just consistently measuring the completely wrong thing? Because truly understanding the difference between consistency and accuracy genuinely changes how you view the world and all the information presented to you. Thank you so much for joining me for this explainer. If you found this breakdown helpful and you want to keep exploring the fascinating world behind the data, please make sure to like, comment, share, and subscribe to this channel for more clear, structured dives into research methodology. See you next time.